Hello, welcome to today's video where we're adding an extra layer on top of what you may already know about the sine rule, because we're looking at something called the ambiguous case of the sine rule. But what are we talking about when we say that? Well, we're talking about a situation where you've got a triangle and you've been given one of the side lengths as well as the angle opposite that side length, and you've been given another side length and you're tasked with finding the angle opposite that by using the sine rule in whatever format you've come to know the sine rule as. The reason this is then sometimes known as the ambiguous sine rule is that there's sometimes more than one answer for what that missing angle could possibly be. That means as a result, if given certain information, there's potentially more than one triangle you could draw with that given information. For instance, if we look at these two triangles here and here, we could actually look at them and realize they both have the same length over here, and they both have the same angle here, and then these two lengths are the same as each other, but they're at a different angle to each other. And so that's why we have the ambiguous sine rule, because we're able to draw two different triangles given two of the sides and one of the angles. To help get an understanding about why this happens, some students choose to look at this from a geometric point of view, because if we know this side length here, you could pretend this side of the triangle was made with a bit of string that you were then able to freely swing around until, keeping its length the same, we'd end up lining that side length up with the straight line we already had on the bottom of the triangle. However, it can sometimes be a bit of a headache to try and visualize this for certain cases, or just when you're under the pressure of trying to solve a question. So instead, I personally prefer to get my understanding of this stuff by going back to algebra or numbers to understand what's going on. Because whenever you're trying to use sine rule to find an angle, it's ultimately always going to boil down to trying to solve an equation of this format. Sine of the missing angle equals a known number. I know I've written it as a k here, but when you're given the side lengths, that would boil down to an actual number. Crucially, the angle we're trying to find has got to be between 0 and 180, therefore this stuff is just boiling down to solving a trigonometric equation, and everything we're doing here is just consistent with what you already know from that chapter if you've covered that content yet. And if you haven't, just as a quick run through, you could either leave this stuff until you have covered that content so you're comfortable with it, or just for the sake of today, just know that you always get the first solution from a trig equation involving sine by using arcsine or sine inverse, sine minus 1, whatever you want to call it, and then you can always get a second solution to the equation by doing 180 degrees minus the angle you found from using arcsine. Of course, if you've also covered what radians are, you should also know that alternatively this rule for finding the second solution changes to pi minus that first solution, but don't worry if you haven't covered radians yet, because again, that's something I'm sure you'll cover at a later stage. And so let's have a go at an example. And as always with any question involving shapes or graphs, it's always a good idea to draw a diagram, not because you're drawing the diagram accurately, but just so you know where everything is in relation to each other. So I'm just going to draw any random triangle and start labeling the points A, B, and C. So here we go, we've got a triangle. I'm going to label that A, that B, and that C. And so therefore we know the side AB is 7 centimeters. So we have this side length here. We have the side BC is 4 centimeters. That means this one over here is 4 centimeters. And we know the angle BAC, so that would be this angle over here, that is apparently 30 degrees. And we've got to find the angle BCA. So that's therefore this angle over here. So let's call that X for the moment, because that's what we're trying to find. And so therefore, setting up the sine rule, we know that sine of x divided by 7 has got to equal sine of 30 degrees divided by 4. So therefore, with a bit of rearrangement, we come across the fact that sine of x must equal 7 sine 30 degrees divided by 4. And that just comes to 7/8. So therefore, if we want to find what the angle is, we're going to have to undo sine, that's not the proper way of calling it, but you know what I mean, by doing arcsine of both sides. So therefore, the right hand side will now become arcsine of 7/8, which typing into a calculator will get you 61.044, etc., etc., as our first angle in the triangle. But we now know there's potentially a second answer, which can be found by doing 180 degrees minus that first solution we just found. So that's, by the way, why I didn't round my angle to 1 decimal place yet, because we still need to do further calculations with that value, and you shouldn't do calculations with an already fully rounded value. But anyway, in this case, if we do that, we'll get an answer of 118.955, etc., etc. But that now leads to our final answers of 61.0 to 1 decimal place, or alternatively, 118.95 would round to 119.0 degrees as our final answers. There you go. So that's question 1 done. However, the problem is with this stuff, you're wondering, well, how was I meant to know whether that second solution should be there or not? How come we didn't worry about this before? How come there's some exam questions I've tried where there was only one answer? Well, the crucial fact to remember is that angles in a triangle must add up to 180 degrees. So when you're trying to find that second solution, it's always a good idea to find it, but then just check whether it'll actually be possible to use, because you know the total angles can't go over 180 degrees. And so an example of this taking place is this example here. Again, drawing the triangle and labeling the sides. We've got A, we've got B, we've got C, and so therefore the side AB is 10.3 centimeters this time, and it's the side AC, which is 8 centimeters, and we've given that ACB is 40 degrees, so that's 1 over there, and then we're trying to find the angle ABC, which is this angle up here. I'll call it Y this time, and so therefore, again, setting up the sine rule, we'll get sine of Y over 8 equals sine of 40 degrees over 10.3. So therefore we can do some rearranging to find that sine of y is equal to 8 sine 40 degrees over 10.3, which comes to 0.499252, and then some more decimal places. I've truncated it there. But then we therefore know our first solution that we know for sure will always work by doing arc sine of that number. And that will get you an answer of 29.950, etc., etc. So what does this tell us? Well, it tells us that actually, therefore, there's only going to be one solution to what our angle ABC can be, which is the 29.95 after we've done some rounding, which would therefore round to 30.0 to 1 decimal place. And that's going to be our only answer. We're going to reject the other one. But how? Why? Because at first glance, 150 seems perfectly reasonable. It is less than 180, which is what we wanted. But remember, it's not just the individual angles themselves that have got to be less than 180, but it's when you add them all together. They've got to come to 180 when you add them all together. And the problem is, if we had that 150 angle included, then we'd have a problem, because if we do 150 plus the other angle we already had, which was 40 degrees, we're already above 180 degrees. So it's impossible for the triangle to have that 150 degree angle, because it would mean the total angles in the triangle would be above 180, which is not possible for a triangle. So therefore, basically, with the ambiguous sine rule, you should always calculate the first angle as normal, and then always try to calculate the second angle by doing 180 degrees minus the first angle. But once you've calculated that second possible value for the angle, then check if you combine it with the other angles that you were given for the triangle, whether that will lead to the total angles being above 180. Because if it is, you can therefore reject that as a possible angle as a result of our knowledge of triangles. Okay, therefore, that is all I wanted to cover in today's video, and hopefully I'll see you in a future video. As I said, if you didn't know where that 180 degrees minus the angle rule came from, wait until you've covered the stuff doing trig equations, because that's a rule that's going to be used a lot in that content as well, so it's kind of just reusing knowledge from that same chapter. Okay, have a good one. Goodbye.